What we're going to talk about is how to control CRUD, what are the means by which you can define and manage your subscriber, and what are the technology you can use to do that. First of all, a little bit of introduction. I am Matteo. I'm an Italian guy. I'm really into pizza and pasta, but since this is not a gourmet conference, we can talk about all these things offline. Just come grab me. From a professional perspective, I spend a lot of time working on web and cloud-based application, and then I joined Open Networking Foundation, and I'm currently a member of the technical staff. The most important thing is that I'm a developer, like I think most of you, and this talk will be not too technical. We won't see any code, but is a talk from a developer for other developers. And what we'll try to see is what are the UI that we are auto-generating for you from the data model, how this whole process works from export to the different access technologies we expose northbound. How can we extend this UI to enable custom functionalities and new services in a CRUD pod? And how can we use those to operate CRUD in production or in a field trial? Before moving to that, I want to spend a few minutes to understand what controlling CRUD is about. We talked a little bit in the overview in Scott talk yesterday, in Sapan talk this morning about this backend. We refer to a backend for every kind of unit we want to introduce in the system. Those are the things that we really want to manage at the end. These backends, VMs, containers, ONOS application, P4 programs, whatever, are managed by synchronizer in XOS. This synchronizer receives data from the data model living in the core that expose northbound different interface. We have TOSCA, we have REST, we have a graphical user interface, and we have WebSocket. The important thing is that the data model in the core exposes a gRPC API to which all these containers are connected. So if you have the need to have a different northbound interface, you can write your own adapter and plug it into the gRPC API. Okay, another important thing to define is who are our users, because that will define the kind of interface and the kind of functionalities that we expose northbound. And we mainly identify two subsets of users. Operators that in general want to deploy CRUD, attach a subscriber to the access devices, deploy some services for it, and monitor the system. And they have a certain set of expectations. They want to do bulk changes on the subscriber. They are managing maybe something like 10,000, hundreds of thousands of subscribers, so it's not even conceivable that they'll manage them one by one. They want to receive a constant status report of the system to verify that everything is up and running. And they want to have a real-time notification and feedback on what the status of the system is. And then we have developers. They have a completely different job that is not make sure that the platform is running, but they have to introduce new feature on top of it, and they need the platform to be stable. Their expectations are a set of stable API that needs to be well documented and accessible for everyone, and they need debugging tools. Now we'll see how we can generate a common interface that will solve all these issues. The mean by we are generating it is the generative toolchain. A lot of people have talked about it. It's called OXGen. And what we're going to see is the journey that our X-Proto files take to arrive all the way to the northbound. We have seen this syntax a few times this day, so I'm going to go over it really quickly. This is the definition of a service instance. In practice, is the instance of a service for a particular subscriber, and we can define some options for it and some fields, some relation, but we have gone through this. Xproto and the toolchain is an extensible toolset that we can use and forge to achieve different behavior. We have extended this tool, supporting some options for the GUIs at the models level, so like the app label, TOSCA description, if we need to hide it from the GUI because it's an internal model that we don't want to expose. And we have some options that are targeted to the single fields in the model. So we can define help text. We can define a set of validators like have a default value, maximum length, if the field is required or not. We can give him some more context with a verbose name. We can hide a single field in a model or provide some choices in some cases. How does all the three? I had a nice animation on these slides, but it went away for some reason. How does all this work? It all starts from Xproto, and then by different means, through different X targets, we are generating either a gRPC API, a JSON description, or some Redis events. On the top side, from the gRPC API, we are passing that API to Chameleon. We'll see how it works later. We'll see how all the third column will work in detail in a few minutes. But we are generating gRPC API. Chameleon has the ability to read it and transform it into a REST API. XS TOSCA read the same information from the core via gRPC and generate TOSCA definition, and there's an endpoint that let you push TOSCA recipe. We generate this JSON description of the data model that the GUI can read and auto-generate some part of the web interface. We'll see how we can combine that with custom views. And we define which models need to send event to Redis, propagate them through WebSocket so that anyone in the system can have real-time notifications. All of this is made possible by this set of containers that represent what we call the core services in CRUD. We have this three-level Larry described yesterday in his technical overview. All the model information are contained in the core and propagated to the northbound via gRPC. Now let's go to dive deeper in this single technology. We have TOSCA to enable well-adopted standard in the cloud environment to be used in CRUD. From the data model, from the same Xproto we have seen before, we can generate a TOSCA description. So all the properties of our model are defined, and we can just push and validate against them TOSCA recipe. This is a recipe for the same description. The way this works is that the TOSCA container is contacting the core container and via the gRPC API and asks to receive the Xproto definition for all the models. These Xproto definitions are used to generate TOSCA definition that gets exposed via REST. So in any time on a live system, you can just query an endpoint and see how all the definition for your models looks like. Once this process has completed, the TOSCA container also exposes a random endpoint that can receive a TOSCA recipe. And again, going back through the gRPC API, will push data in the data model. This UI is normally used to set up the system, to bootstrap the initial data, and to manage multiple subscribers at the same time. As we have seen, the syntax is really YAML-like, and we have support in the build system to generate TOSCA recipes from Ansible templates. So in case you need to manage, to do the same operation on multiple subscribers, you can just write your own template that contains a loop and generate instruction for any number of subscribers. As we said, Chameleon is the guy that enable a REST northbound interface in CRUD. It is basically a translator between gRPC API and REST. It was originally borrowed from Volta. We heard a lot about that project. And what it does is basically expose a Python web server. How can he know about which models are present in the server, in the core? Let's say that we onboarded our new firewall service. This service will come with a service model, a service instance model, and any other model that can help us in configuring it. This information gets pushed in the data model. The core will run migration on the database, will expose this information through gRPC, and will send a notification to Chameleon that, hey, some new models are available in the core, so you'll need to generate new endpoint for all of these models. And Chameleon will generate for us all the create, read, update, delete operation for any of the models in the system. The WebSocket are a read-only northbound interface for now. They listen to changes in the data model and propagate them through WebSocket. We need to have them to provide real-time notification to the user. Unluckily, we cannot read directly Redis event from a browser, so we need this man in the middle. But the most important thing that they enable us to achieve is a progressive caching mechanism in the GUI. We'll see in a few slides what does that really means. Again, it all starts from the core of XOS. Anytime a model is saved, an event is pushed to Redis. Redis exposes multiple channels for all the models in the system. Our container listens to all of them, and based on the content of the message, generate an event that gets pushed to the GUI. And now, finally, we arrive to the GUI. I can get a little bit emotional on this since it is my primary job at ONF. We like to call it the operator portal. Normally, developers love to live in the terminal, in the command line, while operators are more used to graphical interfaces. It is defined by a set of CRUD that stand for create, read, update, delete operation, and views, and a set of custom views. What does this mean in practice? I don't know how many of you are confident with the CRUD GUI, but this is how it looks like. This is the dashboard. We have a representation of the service graph that it's loaded in the system. And this is an example of a custom view. There is no way we can auto-generate something like that for you. But what we can do is auto-generate all a set of tables and forms and relations that let you visualize the system and navigate through them. as you can see, there are quite a bunch of models in CRUD. So the idea of provide default views for all of these models doesn't make any sense, since we have this toolchain to auto-generate everything. What are the technologies involved in the UI? It is strongly based on AngularJS and D3 for the service graph visualization. We make a big use of RxJS, that is a reactive programming library. It let us easily manage complex events. It's completely written in TypeScript, that is a superset of JavaScript. It has the advantage that is a typed language, so we can auto-generate API documentation for it, and we can make developers' life better, providing suggestion in the editor and things like that. It also helps us catching issues at build time instead of finding them when the operator uses it. And all the templating is doing with Bootstrap. That is, I will say, the de facto standard for CSS nowadays. Let's talk about the auto-generated part of the GUI. We start again from our Xproto with all the fields and all the relations that are defined for this model. From there, we generate a JSON list of the single field, identifying if those are relation, what is the type of the relation, if it is many-to-one, one-to-many, what are the validators for that particular field, what is the type, if it is number, text, if it has any option, because we have a multiple choice. On the side of that, we also describe the relation to create the tabs we've seen before in the table, and we get helper information again from the Xproto option, like the verbose name and the description. All this information will help the operator understand what is going on in the system, what that model is responsible for. And again, this is the example of what we have just seen in Xproto. We define a readable name, an help text, all the set of the fields, and if we drill down in the form, we'll see all the other information. Now let's talk about this concept of progressive caching. We have all our set of auto-generated CRUD views for our system. The information to generate these views comes from a service in the GUI that is called Model Discoverers. Is the guy responsible to read and parse the JSON we have seen before in something that we can use to generate HTML at runtime, while all the information to populate that HTML will come from a model store. This model store exposes an observable that is basically a stream of events that is populated as, in first place, by a REST request to Chameleon, and then it will listen for every event for that particular model and propagate the events from the WebSocket all the way down to the view. So anytime something happens in the system, you'll see the model automatically updating in the GUI. You receive a real-time notification in forms of bubble, and you don't risk to have something that is out of sync and seeing outdated information. Other features that are enabled by this progressive caching mechanism are full text search. You can search any model by field, by name, by subscriber in the GUI, since it has the knowledge of all the information that are present in the backend. It let us dynamically populate relational dropdowns, and it enables, of course, notifications. Since we want to enable a quick navigation in the GUI, and we want to make developers happy, we found out that they don't like to use the mouse at all. They would like to stay with their fingers on the keyboard every time. So we enabled a set of keyboard shortcuts that can be defined as global or as per view. And I just want to remember that you can see them by pressing question mark. So if we look at the GUI again, we'll see that in the home page, we'll have just the default shortcuts, while if we go to any other page in the system, some new possibility have came, so we can easily navigate through the models or back, and based on where we are, if you see here, they are changing. All the thing we are seeing now in the GUI are things that we can easily use from any part. We'll see how to extend it and how we can access all of these features and extend them. Debug is something that is really important for developers, because you create your service, you try to operate it, and you don't see things getting reflected in the UI. Or not happening in the backend. So we want to enable two different kinds of debugging tools. The first one is to check what are the state in the backend. Sapan this morning put attention on the feedback state that we are receiving from the synchronizer. This is not normally displayed in the GUI, since it's not an information that you technically need to run the system. But if you want to see the feedback state for a single model, you can press A while looking at that model, and this debug tab will happen, and you'll have all the information on the synchronizer status, the policy status, when it has been updated, when was the last change, when it was created, et cetera, et cetera. Instead, if things are happening in the backend, but not in the GUI, you can just open the browser console, and while by default the bug is disabled, we can enable it to receive messages, or we can decide to see events coming from the backend, and this will give us information of what is happening in the system, and we can drill down and see what is really going on for that particular page. So, extensibility. What CRUD want to provide is the ability to deploy rapidly new services in the network. When you deploy a new service, you'll also need to operate it. And given the complexity of the service and the quantity of services that you can define in a space that is as wide as networking can be, it's impossible to find a solution to generate a one-size-fits-all validation. So we'll let you know, extend the GUI, and we have different means to do that. We can define custom views that can come with your service, or can come with a set of service in case you want to manage multiple information. One example of that, any of these views can access any of the API provided by the core, and any of the components that are available in the core. So as we have seen, we have debug information. We can pipe information to that. We have keyboard shortcuts. We can extend them. We have a definition of all the models. We can read those information to display some information in our view. An example of that is the RCRD, the residential CRD subscriber dashboard. This combines a set of models that we find useful to have in the same place. So for a subscriber, we can manage his current status, if it is enabled, suspended, or whatever. We can manage his uplink and downlink speed, and we can manage the set of devices that are enabled in his subscription. Now, before moving to the next mean to extend the CRUD UI, we need to clear a concept that is about UI components. Has any of you heard about this before? Great. So a component in the UI is basically a set of HTML, JavaScript, and CSS rules that combine a set of functionality in an isolated entity that we can include in any set of page. We are using this component, for example, the form we have seen before, take a model and a configuration to be automatically rendered. And we use this component to give you the ability to extend the GUI in some custom places. Some of these components, just to give you an idea of what I'm talking about, are this form is a single component that gets a configuration and based on that knows how to configure itself. We have another component that just takes care of rendering this tab and navigating the user to the correct place. And we have another component for the navigation, a component for the search bar, and so on so far. What we let you do with this component is to inject them in different parts of the UI. For example, in the dashboard, in the sidebar, in the navigation. Those are the places we define, but if there is any need to create new spaces for them, that's absolutely not an issue. And as views, components can take advantage of all the helpers method provided by the core. And they can integrate other components inside themselves. We have this service that you can use to define where you want to inject a component, what that component is, what is the parameter we need to pass to that configuration, if there is any text that must be transcluded inside it, and if we want to override the existing components that are in the system or not. Let's see a really quick demo of what this means. Now I'm going to do this manually, but any of the extension you can possibly write for the system can do absolutely the same thing. So what I just did is just loading the service to inject this component, and now, I'm just going to inject the same component we have seen the code before in the dashboard, and we see that it appears there. This is a trivial example, but you can think about putting analytics there, putting shortcuts to manage your subscriber, enable disabling services such as firewall, parental control. It is designed for the developer to be as flexible as possible and for the operator to have whatever they need in the correct place. How does this extensibility work? It is available through runtime loading of separate client-side applications. This is based on Angular models, and at an high level, this is the process we have. we spin up a new container containing all the code for our extension and the instruction that knows how to build that extension. It will go on, build the file, minify them, push them to a shared volume that is loaded in the XOS GUI container where the core is. And we go in the data model, we create a new model for our extension. An event is pushed to Redis. Redis notify the WebSocket, and the GUI goes and load those files that are now available in the container. Since all this structure is complex, we created an automated generator to help developers in getting started with their application, so they don't have to write a lot of boilerplate code. It is based on Yeoman, that is the de facto scaffolding tool for a UI application. And it set up the skeleton and the development environment. So I want to spend a few words on this development environment. CRUD is a big system. It requires a lot of resources. To boot, we are doing a lot of work to scale it down, having smaller setup. Now you can run a minimal version of CRUD on your laptop for development. But for UI development, the idea of rebuilding a container anytime I make a change is not acceptable. So what we do for you is we create through Yeoman a standalone web server on your machine, and we can proxy the request from the GUI that is running on your machine to any pod that is running. This is really helpful also when you have to debug issues in the system. You can just connect to wherever you want. The generator is just available in the code when you download it. There are instructions coming with the code. Once it's set up, you can just go in any folder inside the CRUD repository and type this command. It will ask you a bunch of questions. Where do you want your extension to be created? What's the name of it? What's the description? How can I describe it for the UI, etc. And it will, in something like 3 minutes, just generate your extension and print the instruction to load it in the system. We talked about helping developers in their life, and documentation is not strictly a UI of CRUD, but it's something that is needed for people to interact in the system. We realized with CRUD 2.0 and 3.0 that we didn't do a great job in providing documentation and examples. And having a growing community that is growing at such a fast pace is not conceivable to live without it. So we decided to change completely approach on it. We moved away from the wiki, where we are just keeping long-changing information like about the community, about the overall design. But all the technical documentation now lives on guide.opencrud.org. That is generated through Gitbook. Gitbook is an open source project that lets you write a set of markdown files, check them in with the code, and then it combines them and generate a website for you. You can also export it in PDF or ebook format in case you need. So now what we achieved is that the technical documentation is living together with the code. We can do reviews on the documentation as you submit the feature. We can encourage people to write documentation for their feature in order to get those merged. Another really important part of the documentation is the northbound API documentation. The documentation for TOSCA is generated by the container, and we have a job that a Jenkins job that generate documentation for the REST API. They are generated from exploit again, and they are exposed via Swagger. You can just navigate to this link on the guide to see the documentation for all the released service. We can pick one of them to explore it. We'll see all the endpoint available for those model, and we can also see a description of the model. This same exact documentation is exposed at runtime by Chameleon, so we can just go to there and try REST request to the system through this same interface. As last, I want to spend some time talking about the roadmap. We had a great overview this morning, but I want to be a little more specific on what our plans for the UI. As first, we have said this a lot of times in these days, but we spent the last release in making developers happy. The trend for the new one is making operators happy. So we want to get a better reporting of the feedback status. We are thinking about enabling desktop notification and push notification. And we had requests to see a list of events and notifications that happened in the system. We want to improve the build, and in this particular case, I'm talking just about the build of the UI component. We want to move to the multi-stage build of Docker. Is a new feature that enable you to have multi-step build and reuse layer of the container for different things. So having multiple containers that share the same base, in the case of the extension, this should cut down by a lot the time of the UI build. We want to make the file we are downloading smaller and loading them on demand just when they are needed to make performance in the GUI better. And most of all, we want to redesign the service graph. As now it is available, it is there, it gives you a bunch of information, but sometimes it's confusing because it's not positioned correctly, it floats around. When it receives too many events, it has some bouncing issues, so we want to spend some time improve the positioning. We want to absolutely add feedback state to the graph itself, so the developer doesn't have to, the operator doesn't have to track down the state through different pages. And we want to support constraints on the graph. This is mainly to let the operator define what the positioning of that particular graph has to be. I just started thinking about that, but we have plenty of options. We can think about visualizing the graph in 3D on multiple layers with a chain for every single subscriber, or remain on something, let's say, more traditional, but still layered. We can see in the first layer the service chain. On the second layer, the service instant chain for any particular subscriber, and we can think to add more layer on the bottom showing where are the VNF are deployed, what are the compute nodes that are available, how are they connected together through networks, etc. Another thing we started thinking lately is to provide a command line interface to investigate CRUD. We have already something on that line that is called XOSSH. This is a developer tool that the core team use a lot. It's not really well documented, but we are working on it. And we want to create a wrapper around it. Why we want to create a wrapper? XOSSH exposes a Python interpreter that is perfect for developers. They can even test small chunks of code inside there, but it has a syntax that is not really user-friendly. For example, to select all the slices object, we have to do slice.objects.all parentheses, and we want to arrive to something more operator-friendly, slice, list, slice, get, whatever the name of the slice is, and so on and so far. Here, I ask you to get involved with all these things that we want to do on the UIs. Mostly because it's really an interesting project. We are using interesting technology, and we want to make networking better. We are using something that is really cutting edge. Not all the company has the possibility and the flexibility to do that. And most of all, because we are a fun community. We are really open, and we love to learn from each other. About learning from each other, I wanted to close my talk spending few words on the requirements. You guys are the users, and this is really your call. We can think about things that you may need, but no one better than you knows what you need to operate a platform, to debug a platform, to get the information you need in a quick time. So please give us your feedback. We have a bi-weekly meeting on the UIs. It is Monday, 10 to 11 a.m. On the Pacific time. The next one will be next Monday. If there is interest, we can do as per we are doing with the TST, having one time in the morning, one time in the afternoon. So we will reduce the time zone overhead in case someone is far away. But please come in and give us feedback on what is working, what is not, what you would like to see changed, and really anything. So thanks for attending this talk.